The first concept that we're going to look at here today has to do with something called the midsegment of a triangle. And so this is 6.4. It's a single slide. It's one concept that has two sort of properties to it. So let's define a midsegment first. So the midsegment exists in a trapezoid as well. We may or may not, I can't remember if we cover that this year or not, but the midsegment of a triangle is going to be defined as the segment that connects any two midpoints of the sides of a triangle. So if we look at this triangle here down below, you can see from the label inside that definition box, but if we create from here, if we say here's a midpoint and here's a second midpoint, so the markings indicate that we have two midpoints. And this segment right here is called a midsegment. Okay, now, if we do the same thing from a different perspective, let's say we take this point right here and we mark it as the midpoint. This is also a midsegment. And then we also have as a final here, any segment that connects two midpoints in a triangle is considered a midsegment. Okay, so that's just the definition of it. Okay, the triangle midsegment theorem has the two properties that you need to be aware of. So I'm going to label my triangle down here really quickly. All right. So if we look at the relationships that exist between or within a triangle regarding the midsegment is one of two things. All right, so here's the two things. One, a midsegment is parallel to the third side. So when we look down here, DE is parallel to AB. If we look at that, side EF is parallel to CA. And again, if we look at this side, DE is parallel to side BC. So the midsegment is parallel to the third side. And then the second property is it's half that third side's length. So once again, if we kind of look here, DE is 1/2 of AB. If we label in terms of EF is 1/2 AC. Okay. Now, for both of those, I use the perspective of we're finding the midsegment in terms of the third side. But we can also use that relationship to find the third side, right? So if we wanted to find this third side BC and we know that DF is 1/2 of BC, then BC is going to be what compared to DF? So if DF is half of BC, then that means that BC is twice DF, right? So you can think of it in either of those, and that's what you're going to be asked to do. So these two first problems here are on the right side. These are the two like straightforward applications of that relationship. Okay, so if we look at this problem, we see that WV and ZY, those are parallel to each other. We see that ZW and WX are equal, meaning W is a midpoint. We see that YV and VX are equal, meaning that point V is a midpoint. Therefore, when you draw the segment connecting those two midpoints, this is a midsegment. Okay, so if WV is a length of 63, then what does that mean ZY would have to be? ZY is double that. So you can either use the calculation, or if you were calculating 2 times 60 is 120 plus 2 times 3 is 6. So you would get a total length of 126. So that would be the first relationship. Okay, see if you can solve that second problem. Again, these are two that should be able to be answered very quickly. And what would be the length of ZW if you know what TY is and it's a mid-segment? So again, you're being told that these are parallel, although we don't even need that to know that it's the case because these are two midpoints. TZ and ZY or ZV are equal, YW and WV are equal, so we know we have a mid-segment here. And if our whole length TY is 36, then ZW has to be what? Half of that 36 or 18. All right. So this is the straightforward application of this concept, this relationship. All right, this problem down here at the bottom is the more advanced or the more challenging application. I want you to try this. See if you can answer this question on your own. Okay, I'm going to show you two ways to solve it when I go over it. I'll show you the way that most of you are probably approaching it, and I'll show you like an easy way to work through it. Okay, but I want you to come up with an answer. Once you get an answer, compare it to the people sitting near you, see if you got the same thing. All right, so the first thing I'm going to do is I'm just going to kind of sketch what I have, right? I have this equilateral triangle, so that means all three sides are the same. And the perimeter is 88.2. That means if the perimeter is 88.2 and all three of these sides are the same value, that means that 3x is equal to 88.2. Or if I divide by 3, I get the length of each side. And when I do calculate this, I get each side to be 29.4. All right, so there's step one if I'm solving this with multiple steps. Once I have this, I can then sketch in one of my mid-segments. I'm looking to find the sum of all three mid-segments. So if I just find one of them, I know that these are a parallel, and this is 1/2 the length. So if I take 29.4 and divide by 2, that's going to give me the length of my mid-segment. And so when I do that, I wind up with 14.7. And so this length right here is 14.7. There would be step 2. Now, how many of those mid-segments am I going to create? I want to add all three of them. They're each going to be the same, right? And so I can take 14.7. Oops, I'm going to get over here. And I can multiply that by 3. And that's going to give me my overall answer, which here again, 3-step problem. I get 44.1 as my solution. All right, so that is the way to solve this if you're just calculating it, if you're going to calculate all the relationships out. Okay, but there is a way that you can, if you understand it and see it, make this even simpler. Okay, and that is, if I just took one pair of sides and mid-segment, what's the ratio between those two? The mid-segment is what compared to the side? Half of it, right? Now, is that going to be true for each pair of sides and mid-segment? Yeah, so that means the perimeter is also going to have that same ratio. So the ratio between the mid-segment's perimeter and the perimeter of the original triangle is also going to be 1 to 2, and what is 1/2 of 88.2? If I calculate that, I get my answer, 44.1. So if you understand how that works, all you need to do is take the given perimeter, divide by 2, and that's going to be the total sum of the three mid-segments, okay, or the perimeter of that triangle formed when you connect all the mid-segments. All right, so that is the first section, 6.4. That's the only thing that you need to be able to do on there is to work through the two properties of the triangle mid-segment as being it's parallel and on 1/2 the length of the third side. Questions on that before we move to the inequalities? All right. 6.5 has two concepts in it. This first one is split into two parts based on your perspective. Are you focused on the angles first, or are you focused on the sides first? And then the second one is just like for a triangle in general. But these are the inequalities that exist in an individual single triangle. Okay, so the very first one here, or the first two, have to do with the relationship in any given triangle between the side lengths and the angles of the triangle. Okay, and that is that in a given triangle, the angle that's opposite the longer side is the larger angle. Okay, now, there's two other relationships that work with this. Okay, and that is that the angle opposite the shorter side is going to be smaller. And then it also would make sense that the angle opposite equal sides are equal, right? And we've already kind of seen this with that definition of the base angles of an isosceles triangle, right? So this is just kind of extending that out. Now, in any given triangle, longer sides are opposite larger angles. Larger angles are opposite longer sides. So those are these two perspectives. It all depends what you start with. Okay, so here in this example, if we're looking at the problems here, we see that opposite angle A is a side of 5, opposite angle C is a side of 8, and so we know which of these is the larger of the two angles, A or C. C is opposite a longer side, so angle C is a larger angle. And so these are just comparisons within a given triangle. The second box has the same relationship, but now with the perspective of you know what the angles are. And so this is in a given triangle. The side that's opposite the larger angle is going to be the longer side. And once again, it allows you to expand this to the other relationships. The side opposite the smaller, or the shorter, smaller angle, sorry, is going to be shorter. And sides opposite equal angles are also equal. Hey, we saw this with the converse of that isosceles triangle relationship. So I want you to see if you can use that relationship here to answer the question right below. Okay, so again, just looking in the one single triangle, can you determine here which is longer, AB or AC, based on just what you see? Oh, actually, before we get to that. Coming up here, when we look in this one, when we're dealing with if we know what two of the angles are, we actually know what all three angles are, right? If we know 2, then we know 3, because 50, 30 is 80. That leaves 100 degrees for this last angle, so we actually know all 3 angles, even though only 2 are written. And so if you were solving for this, you would be able to see that the shortest side would be AB, the next shortest side, or the middle length side, would be BC, and then the longest side is opposite the 100, which is AC. And so you can actually conclude the whole relationship or the comparison between all 3 sides using this property. All right, so now go ahead and see if you're just comparing AB and AC, which one would be the longer side based on what you see in that triangle. So for a problem like this, what you're looking to do is, are you just comparing the sides that are given opposite the angles? So are we comparing BC and AB? No, we're comparing AB, but we're comparing it to AC. So what we need to know is we need to know what is angle B. So you do have to find a measure of angle B first. So we'll use triangle sum, subtract the two given angles, 82 and 50. And if you do, you see what's left. So this angle is 48 degrees. Once you establish that angle of 48 degrees, we're comparing AC and AB. Well, AC is opposite 48 degrees, AB is opposite 50 degrees, so which one's going to be longer? The one opposite 50 degrees. Again, the side opposite the larger angle is the longer side. All right. So most students are, like they do fine, they kind of get that relationship, and it is intuitive. Okay? If you just sketch what you see, like if you sketch using a right triangle with one leg much longer than the other, and you can tell this is the shortest side, this is the longest side, this is the middle side, and just look at the angles. You know that 90 is the largest it can be in a right triangle, and when you compare these two angles, you see that this is much smaller than the one that's considered mid. And so you can always recreate this on your own if it's something where you kind of forget what the rule is. So it does pass the eye test, and that allows you to figure the relationship out. All right, this second question here to the right is one that has a common mistake that a lot of students make, because the rules that we are talking about in this whole section 6.5, including the one on the next slide, has to do with relationships that exist in a single triangle. It's not two triangles kind of put together in a diagram. And so when you apply this rule of in a given triangle, sides opposite larger angles are longer, sides opposite shorter angles are smaller, and in that it only exists in a given triangle. And so I want you to see if you can find from these measurements given and the diagram provided with the two triangles attached, can you find what's the longest side in that figure out of all of the sides? And so see if you can figure that out. Again, if you get an answer, compare with the people sitting near you. All right, so I see a few of you have made your attempts. All right, so let's talk through like the process for approaching this problem. Okay. Because the rules are for relationships that exist within a single triangle, an individual triangle itself, and yet we're dealing with two triangles, what we're going to use is the process of elimination. Rather than trying to find what the answer is, we're just going to eliminate the sides that you know cannot be the answer, and then we'll see what's left, and you should be left with just one answer. All right, so we have all of our angle measures are labeled here. So let's start looking within one of the triangles. So let's look at EGH first. So if we consider triangle EGH, what's the longest side in that triangle? GE, right? No question. There's like that fits the pattern. That's intuitive. And that is our answer. What that means, though, is that EH and GH, those cannot be the answer. So I'm going to use process of elimination, and I'm going to get rid of those two. Now let's move to the next triangle. What's the longest side in that triangle? The largest angle is 75. So we go to the side opposite it. So the longest side in this triangle is EF, which means I can eliminate FG and I can eliminate EG. So that leaves me with only one side left. That is my longest side. And so the answer is going to be FE. Everybody kind of see how I did that? Use process of elimination, okay, because the most common mistake is to just take the side that's opposite the largest angle that you see, 102. If you chose that, you would have chosen GE as your answer. Okay, but GE isn't even the longest side in the triangle, the other triangle, EFG, so that means that it can't be the longest side of everything. Okay, and so using process of elimination for that type of question will be your best strategy. All right, so let's look at the final concept here, and then you'll have some time to get your work done. It's still within that same section. We're talking about inequalities that exist within a single triangle. And this is called the triangle inequality theorem, which I will generally abbreviate just with the symbols triangle and the inequality or not equal to symbol. And triangle inequality theorem states that in any given triangle, any two sides has to be greater than the third side. Okay, so any two sides, when you add any two sides of a triangle together, they need to be greater than the third side. So on something like this, the sum of AB plus BC has to be greater than CA. Okay? If I started with CA plus AB, that sum has to be greater than BC. And if I started with BC and add CA, that sum has to be greater than AB. Now, normally you'll know the lengths of these, and so you can just take the two smaller ones and compare it to the longest side. And so there's two types of questions that you're going to be looking at here. The first type of question is this top one, where it gives you all of your values, all your numbers. If that's the case, you're just going to test the two smaller sides versus the longer side. So if I looked at this and I saw 14 and 14, those are my two smaller sides, and I'm going to compare those to 25. Is the sum of my two smaller sides greater than my longest side? Yeah. If that's the case, if that is true, then this can be a triangle. So this passes the triangle inequality. Okay, what if we look at the next example? Here we have 3 plus 6. Those are my two smallest sides, and I compare that to 14. Is 3 plus 6 greater than 14? No. So again, this one was greater than, so yes. This one is less than, so no. So I leave that one blank. Okay, let's take a look visually, and I just want to show visually what happens here. So if you have a longest side of 14, and you have two other sides, 3 and 6, can those sides of 3 and 6 ever meet each other and form a triangle? No, because the closest they can possibly be is 5 units away from each other, right? They can never get closer than 5 units, which means it can't enclose a space. It can't become a triangle. Okay, and so that is the relationship that you want to prevent. Now, what if it were exactly equal? What if it was 14 and it was 10 and 4? Okay, if that was the case, the closest these two sides could ever get would be they touch, but they touch on the longest side. And so it's just a point on a segment. It doesn't enclose a space. So it can't be equal. So that's why these can't be less thans and they can't be equals. Okay? They have to be greater than. That's the only way that you create that space and form a triangle from it. All right, so see if you can finish the remaining three parts to this question. Can you find which of the remaining three are possible lengths of a triangle? Again, you can do it with mental calculations. I'll be writing them out just to explain where my thinking process is. If I have 14 and 21 compared to 32, that gives me 35 versus 32. That is greater than, so yes. Next, I have 14 plus 21, which again is 35, compared to 41. Here, that is not greater than, so those do not form a triangle. And then finally, 21 plus 21 versus 36. Again, 42 is greater than 36, so the last one will work. And remember, if they happen to be equal to each other, so if we come back up and we go 4 plus 10 versus 14, this would be equal to, and that is also a no, right? All right. So that's the first of the types of questions with triangle inequality, where they give you all the numbers. You just have to see, is it true or not? Okay, the second part is one that's a little bit more, the problems that are a little bit more challenging, and that is, what if you're only given two of the sides, and you need to find what are the restrictions on the third side. Okay, so if that's the kind of triangle inequality question that you're getting, the way that you need to look at it is two scenarios. Okay, so there's only two scenarios if you're given two sides of a triangle. Either the unknown side is the longest side or it's not. Those are the only two scenarios. So if we say that that third side is the longest side, if that's the case, then here BC would be this unknown. Oops. And you have this side AC is 210, AB is 135. And so what we want to do is we want to see at what point would this stop being a triangle. So the sum of the two smaller sides has to be greater than the third side. So what we know is that BC has to be smaller than the sum of 210 and 135. So if we added those together, what you would get right there would be 345. At 345, these two sides would meet right on here, and it would no longer be a triangle. So a BC has to be smaller than 345. So if we consider that the unknown is the longest side, we can find the upper restriction. Okay, the other scenario is it's either the shorter side or the middle length side, which would just means that it's not the longest side. Okay, and if it's not the longest side, then what side would be the longest? 210 or 135? 210 would be the longest, right? Here, AC. And so if that's the case, then we have the length AB, which is 135, and then we have this unknown BC. So here's the other scenario is if BC is not the longest side, then what we can see is the point where this stops being a triangle, it would be where 135 and this unknown BC intersect. So if we took 210 and subtracted 135, the closest those could possibly be together would be 75. If it were 75, then they would touch right on that longest side. So it would be it would need to be greater than 75. So BC must be some value that's greater than 75. So this gives us our restrictions. It has to be greater than 75, but less than 345. There's our answer. And now, you don't have to write it out like this all the time because it's like a more straightforward calculation. And the way that you're going to answer these questions is the third side of a triangle based on triangle inequality is going to be greater than the difference of the two given sides. And it's going to be less than the sum of those given sides. So if you find that relationship, you have your answer. So here the calculation is BC has to be greater than 210 minus 135, but less than 210 plus 135. And that's going to give you the answer. Okay. So see if you can apply that whole set of principles to answer this last question, please. So you have 31 and 29. So the difference of those is 2. The sum of those is 60. And so you know that that third side here is going to be greater than 2 but less than 60. And so when we test the value that it asks us to, can the third side be a length of 2? No. Okay, it can't because it has to be greater than 2. 3 or like 2 point something would work, but not 2.